Hello and welcome to Tribetopper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos.
In this video session, you are going to learn about beta decay. So beta decay is generally of two types. One is beta minus and one is beta plus. So beta minus decay occurs when your neutron to proton ratio is too high. If you remember, we learned that alpha decay happens when the proton to neutron ratio is too high, and beta minus decay occurs when neutron to proton ratio is too high. So what happens in beta minus decay? A neutron decays into a proton, emitting an electron and an antineutrino. So neutron is going to split up into proton and an electron, and an antineutrino will also be emitted. So basically, what's the composition of a beta particle? Like alpha particle was helium nucleus, it was two protons and two neutrons. A beta particle is actually an electron, a fast moving electron, so -1 E0. So according to this, then our general equation becomes that if ZXA is your parent nucleus, then by emitting a beta particle, you are going to get beta particle means you have emitted -1 E0 along with an antineutrino, but that has no charge, so we don't need to worry about that. So it's a no charge, no mass particle, just account for some extra energy here and there. So what should be the new nucleus atomic number and mass number to maintain the conservation? So Z becomes Z plus 1 and A remains A, because left side was A, right side you have A plus 0 will give you A, and left side was Z, then Z plus 1 minus 1 gives you Z. So this maintains the charge and mass conservation. So you have this as the general equation for the beta decay. So for example, 90 thorium 234. When it emits a beta particle, that's -1 E0 and an antineutrino, you are going to get palladium 91 234. So 234 remains as 234 because the electron doesn't carry any mass number, and 90 becomes 91. The second category of beta decay is beta plus decay. So in beta plus decay, your nucleus is going to emit a positron, which is positively charged. But how does and why does this happen? So again, some nuclides which have a very high proton to neutron ratio. When this ratio is high, some nuclides they emit beta particles, the beta plus particles. So here a proton splits up into a neutron and a positron. Positron is basically an antiparticle of electron. So if E minus is your electron, then E plus is a positron. So it's just an antiparticle of electron. So when you have proton to neutron ratio higher, in some cases, instead of alpha decay, a beta plus decay also happens. So your nucleus actually emits a it's you can say a breaks a proton, which converts into a neutron and a positron. So the nucleus emits a positron which is positively charged, and of course it is accompanied by a neutrino. So when an electron was emitted, it was accompanied by antineutrino. When a positron is emitted, it is accompanied by a neutrino. So we can see the examples of beta plus decay as, so you have 6C11. Here proton to neutron ratio is higher. So this is going to emit a positive beta plus beta. Plus beta means that is going to be +1E0. Like minus beta was -1E0, beta plus is +1E0. So to maintain the charge neutrality, you are going to get what? You get 5B11 plus a neutrino. So earlier it was an antineutrino, so I had put a bar on the top. Now it's just a neutrino, so that's just a neutrino here. So plus 1 and plus 5 gives you plus 6 and 11 remains 11. So that is a positive beta decay. We can have one more example. 11Na21. This isotope of sodium gives you 10 neon 21 by emitting a beta plus, a positron, and a neutrino. So these are the two decays that happen. Beta minus decay happens when you have too high a neutron to proton ratio, and beta plus decay happens when you have a too high proton to neutron ratio. In beta minus decay, we had a neutron. It was decaying into a proton and emitting an electron. In beta plus decay, it's a proton which splits up into a neutron and a positron. So that's all for this video session. In the next video session, you are going to learn about the gamma decay. Thank you.